Hello, YouTube. So, I was over at the European Space Agency's website, catching up on some articles, and I came across a really terrifying one um, about the significant sea level rise. Um, this is an article from back in, or well, it was September the 25th, but I haven't heard anything about this. No one's talked about it. And this is a very big deal. This is very significant. And so let me read it here. Scientists are gathering in the Azores this week to share findings on how satellite has revealed changes in the height of the sea, ice, inland bodies of water, and more. Of concern to all is the fact that global sea level has not only been rising steadily over the last 25 years, but recently it is rising at a much faster rate. The 25 years of progress in radar altimetry symposium gives participants the opportunity to share information gained from this particular sort of satellite instrument. Radar altimeters record the surface topography along the satellite's ground track. They precisely measure the height of water, land, and ice by timing the interval between the transmission and reception of very short radar pulses. This is the only technology that can measure systematically and globally changes in the height of the ocean, and is therefore essential for monitoring sea level rise. The 25-year record of altimetry data allows scientists to determine trends. For example, between 1993 and 2018, the global ocean rose 3.2 millimeters every year on average. But altimetry measurements also reveal that over the last 5 years, since 2013, the global ocean has risen on average 4.8 millimeters a year. Um, another another study that I saw said that it was actually 5 and higher. And in some areas, it's not uniform. It's not a uniform rise like you would expect to see across the entire planet. Some areas, it's risen 10 millimeters a year. Okay. In some regions, it has actually um, dropped. So, how do you figure? How do you go? I mean, how does that happen? Unless the Earth has rotated or shifted, that would definitely cause it to rise in areas and drop in areas. But on average, let me pull up this diagram here. So we see that here we got, okay, 2013 to 2018, 4.8. But this is just in the past 5 years. So for 20 years, it's been climbing, but now it's drastically climbing. So what changed? They say that they're blaming this on emissions and climate change. I am sorry, but I'm having a real hard time with that one. Um, I really am. Let me go back here to. I was trying to find this other article about this. Let's see. ESA. No, it's not what we wanted. Let's go back. No. Oh, shoot. No. Well, hang on here. Let me get back to it. That's just alarming. It really is alarming that over the past 5 years, that's a really a dramatic increase. Let me get to the video on this because it's let's go space news. Here we go. Right right down here. What do we got? Gaia? No. 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 I can't believe that I just dropped that article. Here we go. This is it. Okay. With millions living in coastal communities around the world, sea level rise is a major concern. The information we get from satellite altimeters is essential for understanding how fast our seas are rising so that decision makers are equipped to take appropriate mitigating action. It basically, this is the same thing. It is vital that satellite altimeters in the future continue to monitor this. Yes, we know that. Then it starts to say that blame the biggest cause of sea level rise is as a consequence of climate change, and there are many local differences. These differences can be caused by events such as El Nino, ice loss from the continental glaciers, and from polar ice sheets is also one of the most critical drivers for our rising seas. Ice loss from glaciers, Greenland, and Antarctica amounts for about 45% of sea level rise. But, um, the studies that I'm seeing about Antarctica saying that it's not actually melting, that it's actually, they've got a whole new freeze pack down there. So let's watch this video here. You see a lot from the European Space Agency that you don't see anywhere else. All of the reports about
is constantly changing. Anyone who goes to the beach knows this. From
shorelines receding,
causing waves or still waters, to clouds blocking our sun. The beach is different every single day. But there's one change happening that we don't immediately notice, but it's having a huge impact on our coastlines, and that's sea level rise. This isn't some distant problem of remote Pacific islands losing beach area. Sea level rise affects millions of people across the globe, including here in Europe.
Sea level rise is an uncertainty that we need to cope with. The Netherlands, as the name says, is a low-lying country. Approximately 25% lies below average sea level, and 60% is flood-prone area. We are very fortunate to live in the best protected delta of the world, but we cannot take that for granted. It is an everyday effort to keep it that way, to keep us safe from high discharges of the rivers and sea levels.
But where does all this extra water come from? Mainly from the melting of glaciers and ice sheets dumping fresh water into the oceans and seas, as well as a phenomenon called thermal expansion. This is when seawater expands as it gets warmer, making the sea levels rise. How do we know this is happening? Satellites flying high above our heads carry special instruments that measure the temperature of the sea's surface. Others measure changes in the amount of ice melting off the glaciers and ice sheets. So we know how much ice ice mass is being lost from glaciers and ice sheets, and we can see the water temperatures rising, so therefore we can estimate the overall sea level rise. But how do we know for sure? Measuring in situ, or directly in the water, is difficult because of tides and waves. And even though tide gauges are in place, we must remember that oceans cover 70% of Earth's surface. That's 360 million square kilometers. That's huge. How can we systematically and accurately measure such tiny changes on such a huge scale? That same radar that's used to quantify the loss of ice mass from glaciers and ice sheets can also measure changes in global sea levels on a millimeter scale, and it can do this all over the globe. 25 years of measurements from these radars show
here's our
that the
graph.
global sea level is rising up to 3 millimeters a year on average, and is accelerating. That may not sound like a lot, but think, at a rate of 3 millimeters a year, that's 3 centimeters in 10 years, or 30 centimeters in 100 years' time.
Yeah, but she doesn't say that it's actually 5 millimeters.
The water is not rising uniformly across the globe. We have to take factors into account such as currents or gravity. Satellites can also provide this
Look at this
information to give
globe
scientists
here
more data that they can factor
that they
into
show.
their calculations. In some areas, the sea level is rising by more than 10 millimeters per year.
Look at
While
this,
in others,
10
it's
millimeters.
going down more than 10 millimeters
Going
a year.
down 10 millimeters.
Sea level rise is a major indicator of climate change because it integrates a lot of parameters like, for instance, the melting of Greenland and Antarctica. We have an estimate of 3.1 millimeters per year over the last 25 years, but it's been accelerating in the last 5 years near 5 millimeters per year, so it's a strong acceleration. By 2100,
You think?
we could have a 2 meter rise of sea level.
Well, that's based on 3 millimeters, not 5 millimeters.
Like the dikes we see across the Netherlands. But the only real power we have against the rising seas is to examine the bigger picture of climate change and try to curb our emissions so that we can slow down this process of melting water,
Curb our emissions.
and rising sea levels. If we don't make an effort to curb our emissions, it's not just going to affect our beach space, but impact the lives of hundreds of millions of people
Okay.
in coastal areas who could lose their land.
That's a bunch of crap. If they wanted to curb our emissions, there is a whole lot of ways that this could happen. With our technology now, we could have magnet generators in every home. We could have wind. We could have use the currents. There's so many ways to get rid of oil and gasoline cars and all of this stuff. And you know, there's some articles that I just finished reading that said that thanks to the geoengineering stratospheric aerosol injection program, that they will be able to fix the hole in our ozone by 2047. Okay, by spraying all this stuff, they are solving the hole in the ozone. Well, if they're fixing it and then they're going to solve it by 2047, that means that there's a progressive bettering of this climate change monster. And if that's the case, then why are we seeing a steady increase in the past 5 years since they've started the stratospheric aerosol geoengineering program? It seems to me that it's getting worse. So the data's not matching here with what we're seeing. There's a big bunch of lies going on, and it's killing our planet, and it's all going to come out with it's all going to come out with a natural disaster or something bad. And you know, all of this crap that they're spending money on, the geoengineering and all of these green programs and tax cuts for corporations, none of it's working. So we either need to go back to the drawing board, or we need to start getting real with what's really causing our planet to die and heat up like it is, you know. So I just wanted to drop that on you, and till next time.